Hello and welcome to this video. This is the first in a series of lectures or a series of videos I will make on some introduction to Matlab. So I'm making these videos primarily as a resource tool for students of the course I'm teaching here in the university. However, I believe they'll be quite useful to anyone else who really wants to go through them. So I hope you find this really useful. So I just want to start by talking about a little bit of introduction about Matlab. Now, Matlab really is an acronym that stands for Matrix Laboratory. If you really want to go back into history, it stands for Matrix Laboratory. And I just like to point out that originally Matlab was designed for working with matrices. I like to point that out because Matlab tends to see a number of things as matrices and it really works a lot with matrices. So that if you can think in terms of vectors and matrices, it helps a lot with your programming. Matlab is an integrated environment which runs the Matlab language. So Matlab, you could say, is both an environment and a language. It's a high-level programming language, and that means it is highly human readable. You will see when we get into some Matlab code that really you could look at it and tell what it means really by just reading the program itself. Matlab is interpreted and not compiled. So you could say that Matlab is an environment that has an interpreter which interprets and runs Matlab codes. We'll come back to this thought of it being interpreted and not compiled shortly. So primarily, Matlab was intended for numerical computation, symbolic mathematics, and scientific visualization. So think of the fact that you have some simulations of some mathematical model you want to run. Matlab is very good for that. You have symbolic math you want to do. You want to solve symbolic systems, symbolic equations. You could use this for that. And you want to present your result in a visual form. Matlab is good at that. Now, Matlab has gone way beyond these and does a whole lot more, for instance, interacting with hardware. But then you can really take much of what Matlab does and fit it into some of these boxes. And you'll find out that, yes, this tends to cover a whole lot of stuff that we do in engineering. Matlab is very good at receiving data, processing it, and giving output in some form or another. The output may be on a screen, may be in form of a graphic of sorts, a graph, and a pie chart, a histogram, or whatever, mesh diagram, or it could be the control of a hardware. It could also take in data from hardware. So talking about MATLAB now, it's a programming language primarily based on on matrices. We will see a little more of that when we start really programming. Now, because it is interpreted, I said we'll come back to this. Being interpreted, I like to think of or describe a language that is interpreted as one where you can imagine a president giving a speech in one language and somebody interpreting into another language. As the president starts making a speech, he gets with each statement he makes, an interpreter interprets those statements. So the interpretation is done one statement at a time. That is an interpreted language. Now, on the other hand, if it were possible to take the entire president's speech, read it in English, and now decide, okay, I think this is the best way to pass this same thought across in this other language I want to convert it into, then that process will be called compilation, because then you are taking the entire speech, trying to figure out the best way to actually present it in the other language, and then you now present it in the other language. So you can imagine that compilation will be much more efficient than interpretation, because interpretation, really, you take it line by line and you interpret a line not necessarily in context of the entire program. So MATLAB will generally be slower than languages like C or C++, which are compiled. So you want to avoid using loops wherever you can avoid them. That's one reason why we talk about something called vectorization. Vectorization is something we use a lot because it helps us avoid loops in some cases. However, it is very efficient in the location of errors. So think again, going back to the analogy of interpretation. When the president makes a statement, if you don't understand that statement or you feel there's something wrong, you could ask, sorry, please, could you say that again? And then he repeats himself and you understand that before you can interpret it. And so really you don't go on with the interpretation until that confusion is cleared up. That's the same thing MATLAB does, so that if you have an error on one line of code, it basically stops there and tells you, hey, there's an error here, fix it. After you fix it, then it now goes on with interpretation and probably locates other errors or finishes executing the code. Now, MATLAB has automatic memory management, and this is a beautiful thing. You don't have to define or explicitly declare the data type when you are programming. So you don't have to specify a particular variable as being an integer or a floating point number or anything. So let me just take a simple example of this. So here at the command prompt, I want to declare a variable. We don't have any variable at present. I declare a variable a is equal to 5. I type that in there, and that is that I didn't specify it's an integer. I didn't specify it's a floating point number or anything, and it knows it's an integer. Let's say I say b is equal to 3.2. It knows it's a floating point number. I didn't need to do anything. Let's say I say a is equal to 5 divided by 3. Or in fact, let me say a is equal to a divided by 3. We initially defined a as 5. Now I'm redefining a as whatever value was in a before, divided by 3, and store this new result in a. Once I type this and press enter, notice that a is now a floating point number. So it has automatic memory management. You don't really need to specify what data type it is. It automatically handles that. MATLAB is intuitive and very easy to use. Now, generally, you have a shorter program development time than many other languages out there. This is one strong point of MATLAB, and is one big reason why in the engineering industry it is used a lot. Remember, I mentioned it is slower than C, but then considering the fact that it can take you much shorter time to develop your program in MATLAB, it might make a lot of sense to come up with your algorithm, an algorithm that works well, a super algorithm. Take a short time to come up with that in MATLAB. Then once you have your algorithm all spelled out, you can now go ahead and convert your code into C using the MATLAB compiler, so that it now runs as efficiently as possible. Or go one step further, make it an executable file, or make it a DLL that you can call from other languages along the line. So MATLAB usually is a way to go, and as engineers, this is one language you really want to learn. Many application-specific toolboxes exist in MATLAB. I mean, there are several toolboxes out there. Something that handles neural networks, something that handles radio frequency communications, something that happens bioinformatics. You have econometrics toolboxes. You have several toolboxes out there that work with MATLAB, and so it makes it fun working with MATLAB. Now, we've already had a first bite of MATLAB in the sense that I just typed in a couple of commands here, but let me try to formally introduce MATLAB in the sense that this is the MATLAB environment. When you should run MATLAB, it will probably look like this. I use the word probably because it could be arranged differently. Now here there are three main windows that are available that we can see at present. You have the command window, you have something called the current folder, and you have something called the workspace. There are some other windows that could show up, and I'll come to them shortly. Firstly, the command window. This is where we type commands. Well, that probably goes without saying. We type in commands in the command window like I did earlier on. I could say that, say, b is equal to the sine of pi divided by 2, and it gives me the answer as b being equal to 1. I don't have to assign okay, so in each of these cases here, I assigned the right hand side to a variable name. Now I don't have to assign it to something. For example, I could just simply say find the cosine of pi over 2, and it gives me the answer. But take note that it creates a variable called ans and assigns the result to ans. Now I can use ans like a normal variable, so I could say that c is equal to b times ans plus a, and it gives me an answer to that. Okay, so by the way, hope you notice that ans is approximately equal to 0, which is what we expect. Why is this value not exactly equal to 0? Well, that's an argument people have, but then pi, remember that pi is an approximation, and then you're using numerical methods to do some computation over here. But then 10 raised to the power negative 17, really, this is very close to 0, and for now, just assume that it is 0 that we have over there. So these are one could just type in commands directly in the command window, and that works. Now, you probably have noticed this already, but every time we have a new variable, or we have a new answer, a new solution, it is all stored in this region over here. Now this place is called the workspace, and the workspace holds variables that you have in the current session. Now because something is a workspace, if I just simply type C at my command window, MATLAB knows what C is. MATLAB knows what C is because it is in the workspace. If I type D, the MATLAB will throw an error and tell me it does not know what D is, undefined function or variable. We'll come back to this word function later on, but for now, undefined variable called D. It has checked the workspace and it cannot find it, so D doesn't exist. Now the current folder. The current folder is the folder you are working with on your computer. Presently, I am working in my C drive, my online tutorials, a folder that I called Matlab. I don't have any file in there. Now, we will come back to the current folder, but your current folder is quite important because when you're writing programs, if you save them in your current folder, Matlab will see them. If they are not in your current folder, Matlab may not see them. Okay, I'll come back to that thought, but for now, let's just suffice it to say that your current folder is where you will store your MATLAB programs that you want Matlab to be able to find. Now, take that definition with a pinch of salt, but then that's good enough for now. In here on the toolbar, you notice something called layout. If you click on that, it now shows various things that you can have and talks about how you can arrange this. So for instance, this is default layout that I have over here. Another option is I could have 3 columns where I have current folder, command window, and workspace on the right. Or I could decide that I want all but command window minimized. So the others are now here that I could always bring them out as I want. Let me go back to the default for now so you can at least see what is going on in the workspace as I get on with my work. Now I should mention that the workspace not just tells you the variable names and their values, but can also give you some more information, but I guess we'll get to that a little later on. Okay, now there is something called the command history. The command history gives you history of commands. That's kind of obvious. So it gives you a history of commands, and what Matlab does is at the command window, at the command prompt, if you just press your up arrow key, it gives you your command history. Now this command history literally goes way back. As long as you don't clear your command history, it will literally keep all commands you type. For instance, I'll just do a quick scroll and you see commands that are stored in here. I'm going up, and then it tells these are things I stored 26th October 2018, and today is September 2019, and it has stored a whole bunch of commands that you had in there. So it has this is a command history, and it stores all commands you type at your command at the command window. It stores all those commands. Now, just a quick shortcut I could show you. Now, earlier in this video, I typed a is equal to 5, a is equal to a over 3. Okay, so if I now type A and I press my up arrow key, notice that it automatically jumps to the places where I have A starting the command. So if I press up once again, it goes to A is equal to 5. Let me press up once again. Maybe at some point in time before I made this video, I pressed A is equal to something, and there it goes to A is equal to 50. I could go up again and it shows several things I have done in time past. So that is one way that let's say you want to type in a command, and a command you've typed in before, you just start out the characters you use to type that command, press your up arrow key, and it brings back your history for you. There's one more window which we've not talked about here, and that's your editor. We'll come to the editor when we start writing MATLAB programs. Okay, so we can use this layout button to go ahead and adjust the layout setting and arrange it in whatever way we want to have it arranged. Now, these are a couple of commands we could type in Matlab, and you could think of Matlab as a simple scientific calculator. You could just simply type in commands as is. So for instance, 2 plus 3 will give us 5, 8 minus 1, 2, 3, 4 will give us an answer. I won't try to compute that in my head. If you want to define a complex number, Matlab again handles memory on its own. So for example, if I just simply said 2i, Matlab knows that is a complex number. Matlab automatically knows that's a complex number, and it makes it 0 plus 2i. So I could say that g is equal to 3 times say 2 minus 3 3i, and that works perfectly well. Okay, now this is the only case really where you will have, when you have a complex number, I think that this is the only case, as best as I know, where you have a number and an alphabet standing together, where the number starts, the alphabet follows, and there is no sign in between. So for example, let's say I said that e is equal to 2b. If I want to say e is equal to 2b, what I intend is 2 multiplied by whatever value is stored as b. This will throw an error because 2b is not a valid expression. So I need to put a multiplication sign in between, and then I can now have this. So however, if I said is equal to 2i, this is allowed because 2i is a complex number. It's a single number. MATLAB sees it as a single number. I should mention that MATLAB also sees j as the complex variable. So you could use I, you could use j. That is perfectly fine. You could go ahead and find logarithm to base 10, logarithm exponential of e raised to power minus 10. You could have a sine function. This is a cosine where the argument is in degrees. This is the hyperbolic sine, square root, sine where your variable is in degrees, and this is 2 times 10 raised to power negative 4. So you can just try these commands in MATLAB, and I will encourage you to try them out in MATLAB. It works. They work just like you would expect them to. Now, before I take that slide, one thing I probably want to mention at this point is finding help in MATLAB. Okay, let me not jump the gun because I do have a slide on this. So let me go ahead with this presentation and then I'll come to finding help in MATLAB. So variable names, these are some rules for naming variables in MATLAB. Now these are like in every other language, so I think I can just breeze through this. They must begin with a letter. The names can include a combination of letters, numbers, and underscores. No other special characters, just underscores. Maximum length for variable name is 63. Now I should probably confirm that this is still the case. MATLAB is case sensitive, so capital letter A and lowercase a are very different. Now let me just try to illustrate this. So far all my variable names just happen to be lowercase. Now if I issue the command A to MATLAB, it does not know what A is. Instead it asks me, did I mean lowercase a? Because it found lowercase a, so it feels like maybe that's what I meant. It's suggesting it. I need to press enter for it to accept this. But then capital letter A is not defined at present in my workspace. Now, these following names are built-in MATLAB functions. I, j, and pi are built-in MATLAB functions. You notice I used pi earlier and I didn't speak to it. I apologize for that. But MATLAB knows what pi is. Now, length, char, size, plot, break, cos, log are also MATLAB function. They are function names. And we will see a good number of these things later on. We've already seen cos and we've seen log, at least on the previous slide. It's a good programming practice to name your variables to reflect what they are being used for in the program and not just using generic names X, Y, Z. So for example, if you came and looked at my workspace, what is A, B, C, D, E? What do they stand for? Really, they just look like random variable names, and in your program you probably don't want to make a habit of this because it can become very difficult to read your program later on if you don't remember what a variable name actually does stand for. Now, spaces don't matter as much in MATLAB, so that A is equal to 3 minus 5 gives you the same result as A is equal to 3 minus 5, and gives you the same result as A is equal to 3 minus 5. Give exactly the same result. So all those white spaces really don't matter that much in MATLAB. There are a few cases which are kind of obvious where those spaces do matter, but then I will leave that out for now. If you place a semicolon at the end of any line, it will not display that result to the command window. So for example, if I said A is equal to 3, it actually displays the result here in the command window. But if I said A is equal to, say, 7, and I put a semicolon, take note what happens in the workspace once I press enter. The value changes, but then nothing is displayed to the command window. Now, one nifty command which I will use often, CLC, clear the command window. Workspace remains intact, but the command window is cleared. If you wanted to clear your workspace, by the way, you could just come in here, right click and say clear with workspace, or you could select a particular variable and delete that particular variable, or you could come to your command window and type clear. If you type clear, to clear the entire workspace, or I could type clear space C and it removes just C from the command window. Clear space A, B. It removes A and B from the workspace. I'm sorry, I think I said command window a little earlier. It removes them from the workspace. So in order not to let this video be too long, I think I'll stop this video at this point and I'll take off from here in the next video. Thank you.